Hi everyone, thank you for coming for my talk, and I believe that this talk will be different because I won't be doing any coding. I will talk a lot and I will show you how to hack and how to protect your Flutter apps. So, to start, to warm up, I prepared a short story. This is a real story. Back in the day, I had an opportunity to interview a friend of mine whose app was hacked. His application Better Vision got over 100k installations, and it was really helpful to disabled people all over the world. But with success, however, soon came difficulties. His application was hacked. His application was actually stolen by some malicious reverse engineer who tried and reverse engineered and removed all the protections and sold this application with his own payment gate. So this story is quite common. In the start, there are usually a lot of business requirements. Usually, we are working in a hurry, and doing the security takes some time, and it oftentimes lacks. So my friend's application was stolen, and then it was made available on some third-party store, and he assumes that profits from sales of this application were on Android 4 times lower than on iOS. So it was a huge impact for his business. And this is the start of my reverse engineering journey when I started learning about mobile security, which I'm going to present you today. So I know personally that people are searching for ways how to protect themselves a lot, and especially Flutter people get oftentimes confused because nowadays Android and iOS native apps are a little more mature. But speaking of Flutter apps, Flutter devs struggle with finding the right routines, what's the recommended approach, and they search a lot for practices how to protect their secrets in the application, how to prevent repackaging and publishing of their apps on third-party stores, and they search, for example, how to protect their applications with obfuscation. So this is something we did in Talsec, which is the company which I come from, where we started when we realized that there is this need to protect applications more deeply. So to show you how to hack, I first need you to learn the most common tools which are used by reverse engineers. I prepared something I like to call shopping list, and this is a list of applications and toolkits which are used by hackers to achieve their needs. So the first one at the top is Magisk. Magisk is a routing framework which will give the reverse engineer the power to be a root on an Android device, and this power gives you the opportunity to inspect apps internals, read whichever database is present. Basically, you can do anything if you are root, of course. Another thing is Frida. For those who are not used to or do not know Frida yet, I have I like to say that Frida is like a debugger, which will allow you to go step by step in the application, stop it, and inject your code whenever you need. So you can stop the running of application, add some code to exfiltrate the data, and then proceed. So you can imagine a debugger, but a little bit more powerful. AppTool is tool which is used for Android apps. It's a simple command line tool which will take an APK, which is like a base packaging for Android application, unpack it and makes it like a reverse engineerable, So it will give you access to all the original components which you can then tackle with. Okay, and this is my favorite. It's like Swiss knife for reverse engineering. It's mobile security framework. It is like a perfect reconnaissance tool whenever you need to check under the hood statically or dynamically what's the application processing. It can find you secrets, it can quickly help you find endpoints, servers, whatever its application connected to. It can help you to find a lot of strings and like understand the inner workings of application. So I use it also to inspect applications code because it can also give me some insight into smiley code, which you will see later. Lucky Patcher is, I think it's a little bit older tool nowadays, but it's still used to remove Play Store validation from or license verification from apps, and it has a few other goodies. For example, it can remove ads from your application, and this is used by some malicious third-party stores to take your applications, remove all the paid stuff within it, and republish it in a stripped form. Guidra, this tool leads me to more of like binary inspection, because Flutter apps are in their core binary packed, so you can you know probably that your Dart code becomes some machine code, and if you need to go one step back and read what was the original algorithms or original code, you need some decompiler, and free Guidra comes with one. So on the left side you can see there is some machine code which turns into quite readable C code on the right side. And one of the latest tools for reverse engineering of Flutter apps, which I think is great to know, is Reflutter. This tool gives you power to inspect network traffic. If I will have time in the end, I will show you some quick demo, but you should know that this tool allows you to remove default certification pinning in Flutter apps, and it can help you to establish connection between your application and your burp suite instance, so you can check network traffic and inspect basically every JSON. So that's all I wanted to show you from the tooling, and I will start with a simple hacking of shared preferences, because I can imagine a lot of you didn't reverse engineer application yourself, so this will be some introduction so you have idea. So I always like to imagine applications store data as some gold chest full of golden items and precious coins. So you can see that applications are full of interesting objects like databases, tokens, some configurations files, web authorization tokens, and identities, which are really interesting for hackers. And I will show you a simple demo where I will modify shared preferences. So I've used for my demonstration a well-known shared preferences plugin, which will create a shared preferences file within your application when you drop it. I even copied the example from the docs, and I will show you how to find the stored preferences and how to modify or extract its data. So this is simple code which just has some counter on it, and it's application which does basically count your taps. So whenever user taps this plus button, the counter is increased, and that's all this code does. So I will show you how to access this stored value in stored data. So, but I have a common question, and the common question people give me is that, or they like to think that Android devices at least are secure enough nowadays, and that there are not really dangerous devices, or I would like to answer this common question. So in reality, there still are a lot of what I call rooted devices, or at least privilege escalation enabled devices. And I have a few examples. So first two examples are like obvious. You can have your device rooted. You can take your Xiaomi, Samsung, Google Pixel and root it yourself. Another option to get access to rooted device is to have an emulator which you can root also using, for example, Magisk. And then there are three interesting examples. First is malicious third-party dependency. I don't have an example from the mobile world, but you may remember that like 2 years ago, there was a really well-known vulnerability log4shell. So you can imagine what would happen to applications if there was some security vulnerability in some widely accepted package which is used by majority of apps. Another like a way how to exploit application are, of course, not patched Android devices, because as we know, like vendors don't usually support Android devices well, and Androids in the wild are oftentimes let unpatched with old security updates. And the last one is hardware exploit, and this is, for example, 1 year ago there was a dirty cow exploit which allowed to make some privilege escalation on I think it was MediaTek devices, I'm not sure. So there are also hardware-based exploits which are there, which exist from some time to time. So these are examples of rooted devices or privilege escalable environments which are still present, and you still have to count with them. But back to our example. So I created the application with the counter, and now I'm going to show you how to access the shared preferences and modify it. On the left side, I have emulator which is equipped with Magisk and Total Commander. And if I navigate to data/data/ package of my application, which is com example my app, I will see everything what's inside of that application. So this is the internal of my application, and if I navigate to shared prefs, I will see these two files. So basically the bottom one, Flutter shared preferences.xml, is the shared preference file with the value. So I'll open it, and I can see that the last stored value 3 is over there. I can modify it to 3 to 1, and it is instantly edited and visible in the application. So this was a quick introduction to access applications internals, and I know this may be boring for some of you, but I still think that for a lot of you it's important to know that this actually is possible. Okay, and I will show you this obfuscated example, which is from the application I reverse engineered some time ago, which if you can see those yellow highlighted areas, which contained a lot of precious information for reverse engineering, which could be misused. So I take this as an example. There is nothing, I think, personally identifiable. Okay, and now some hot stuff. Firebase auth token is something everyone uses to authenticate users. So I prepared a simple demonstration how it can be extracted from application. So I just dropped Firebase into my application. This is the website everyone knows. And I created a simple authentication application, filled in my credentials, and registered basically into this application. And this is my account. So what's Firebase auth token? Speaking of application, on the application side, it's a simple file which stored the same way like shared preferences are. So if I will get back to the place, the location where are shared preferences, I can now find this file which contains shared preferences token. I will show you. So I extracted the shared preferences token and inserted into this nice visualizer. So you can see, if I zoom a little bit, there is my account available. What does this mean to you as developers or as app owners? If there is any exploit which can be used to extract those tokens from your application, the attacker may be able to harvest all your users' credentials, but tokens, and impersonate them, which means that your backends won't even know they aren't talking to real devices or real users, and your whole operation will be hacked this way. So you have to protect every authentication token. So let's move on to another kind of hacking, and that is repackaging. I need to show you all these parts, and I will show you the big picture in the end, how it works together, right? So repackaging attack is a type of attack when someone takes your application, removes or alters the stuff you put in, and then tries to deliver it to your users. So this is exactly what happened to my friend in the story I told you in the beginning. This attack is dangerous because it allows attacker to do these things. The first thing is injection code into main activity. If you are former Android developer, you definitely know main activity. That's the starting point of every application. And even in Flutter apps, this code is still available and needed because it starts the application. And an attacker is able to take this class and inject his malicious code over there. Personally, I did some testing, and I was able to inject main activity with a Trojan code or downloader code, which directly extracted those tokens and sent to my command and control server. So this is a really interesting place for attacker. And another example is opening some browser intent. So user may be led to attacker-controlled website where the attackers may try to collect users' credentials, of course, and also other activities like injection of advertisement, which was common 3 or 4 years ago. There was some third-party store which had an automatized way to inject custom advertisement into applications which they collected. So these are real-world examples of hacking with your application. So how this repackaging attack is done? It's really simple. For those who don't know, I don't want you to read those lines, but I wanted just to give you impression that it's 3 or 5 lines of code. So in this one-liner, I open the application and extract everything. There is everything opened. So this is the Android manifest. Then there is a main activity I talked about. So for example, I was able to inject into line 11 a bunch of my own code which was able to read that token. So this is really dangerous. And here is yes, yet another interesting part for reverse engineers. That's the whole like startup code for Flutter engine in Android application. And so to create some clone, I just take main activity, rename the applications package to pwned, for example, replace this package name in like 2 or 3 places, and my application will be ready to be delivered to users. So I renamed the application to correct app, and also this package name needs to be changed. And then these 4 lines to create back the correct application. And once installed, you can see correct app is alive, and I can use it whatever I like. So repackaging is simple. And now the whole chain, the big picture I talked about the whole time. So the attack which you, for example, may need to know about is that your application may be repackaged. Then it can be fitted with some downloader code, as I talked about. It can be split or shared between many users, and attacker will be able to harvest tokens, for example, and then make impersonated calls to your API, and that's the whole chain of attack. Now the hacking part ends and starts a protection part. To protect application against such attacks, you need to employ something called RASP shielding. RASP shielding is a technology, it's acronym for Runtime Application Self-Protection, and it's technology used by banking and fintech industry to protect against various attack vectors. So it gives you the power to detect if the device is rooted, if there are those routing frameworks installed, if the application wasn't tempered, or if it comes from your known store. And this is a really like recommended way if you need to pass penetration testing, because more serious applications are oftentimes required to pass penetration testing. And it also is one part of OWASP MAS standard. It's exactly resiliency category, which requires you to check for these areas if you need your application to be resilient against attacking. It's also used for some IP protection, and there are other connected technologies like obfuscation and licensing. So how this RASP looks and why I'm talking about RASP on Flutter conference, right? So we as Talsec were able to share with general public a free RASP package which you can grab and install to any application and get this basic baseline of resiliency protection. So this is a first package on PubDev which gives you ability to control all the possible controls related to resiliency, and it's available for free. Nowadays it protects more than 500 apps, and we are maintainers, but we like community like pull requests and other stuff, so it's nowadays more community developed, and I definitely advise you to try it. There is a simple example of free RASP callbacks. So whenever your application is being attacked by tampering, for example, this happens when device is being repackaged, when application is being repackaged, you will get this callback which will warn your application what's happening. This is great because you can then protect your user. You can display some widget like don't use this app, it's probably being hacked, or don't use this device because it's being hacked. And on the iOS there are like alternatives which are similar to the Android ones. So on root detected, on emulator detected, on hook detected, on temper detected, device binding and installation source detection are already baked into free RASP, and you can try it yourself. As I said, this RASP technology or this resiliency knowledge is required by mobile application standard in its resiliency part, which is like called R layer. And if I imagine it, the mobile application security testing guide, which is the guide which is used by penetration testers, has 88 distinct categories which are checked, and the resiliency category is this orange one at the bottom. So employing resiliency technologies, you will like pass through this category. Okay, and now to move a little bit further, still the RASP technology can be cut off from your application. So you might feel that I somehow recommend you something which can be removed. It's not so easy to bypass this RASP, right? So yet there are needs to move beyond the client integrity checking and protect the whole chain from your application to your backend side. We like to call this attestation or device and app integrity protection for backends, and this is something which is quite new approach, and it's basically a way how to ensure that your backends stay protected and that your backends will communicate only with your application and nothing else. Because in reality, you need to ensure that your backends are not abused by some third party like hackers who try to just in their pursuit to fuzz your API, or there are no fake registrations, botnets, or impersonated calls. And as well as you want to get rid of some session hijacking attacks or evil middleware admins. So device and attestation technology is really important if you go beyond the traditional and RASP protection. So as I write on the right side, your ultimate goal is to block traffic coming from sources other than your application. In Talsec, we developed a technology for this. We were awarded Ernst & Young award for that, and we called it Epicrypt. And basically, it works like this. On your application side, all RASP checks and all resiliency smart technologies are conducted to ensure that the application and device is valid and that everything's okay-ish. This result is given to your application, and this result is then transferred with every API call to your backend, where this is decrypted, and your backend decides whether this incoming call is valid or not. This is very important because otherwise you could accept calls from some botnets or impersonated users, and I think that this is quite a new approach, and I think that everyone should know about this new technology. So this is a way how to ensure that your backends stay protected. And because I didn't even use all my time, and I have a summary ready, I think we could show you these slides. Okay, so here's extra content. Extra content is application from this well-known car manufacturer. I may be sued for showing it there, so please don't tell anyone. So I took this application and used Reflutter to check its internal workings, its network calls. So this will be a quick demo of Reflutter. I created a refluttered application, and run it. So these lines are again with something you've seen before. Then connected it to my burp suite, and then I could try what all those buttons were doing in reality, because these car applications offer a lot of funny things like honking your horn or switching on lights. I wanted to know how this looks like in their JSONs, so I just connected this application to that burp suite, and thanks to Reflutter, I was able to inspect every call, even the account. So, for example, I was able to find that there is some advertisement injected somewhere. Yes, for example, user's coordinates, a user market is sent, and other stuff. For example, here is a Firebase token embedded into one network call, and that's all about Reflutter. So I will get back to summary slide, and you are free to ask me anything you would like to know about mobile security and specifically about resiliency. And I would like to thank you for coming today, because I am really glad that I could share with you this knowledge. Thank you.